Hello, and welcome to this video on graphing rational functions. If you're looking at this video, we're already under the assumption, one, you know what a rational function is, and two, you've sort of reviewed the major components involved when studying them, okay? Although not the formal definition of a rational function, this is sort of just a little working example for the ones in this video. It's basically a function that looks like a fraction, okay, with variables definitely on bottom, maybe on top, okay. That's you should have gotten a better definition in class of it, okay. So also, we're assuming that these pieces that I'm about to sort of review real quickly are things that you're not seeing for the first time. Comprehensive graph of a rational function includes the following: one, vertical asymptotes, okay. Two, any holes. I'm not going to do any examples in this video that have holes, but that's coming up, and you need to be able to understand that they're very much related to vertical asymptotes. So look for that in the future. Horizontal asymptotes, again, something you should have had instruction on in class. X-intercepts, Y-intercept, and then also we'll talk about generating enough points to fill in the gaps listed in an XY chart. And you'll generate that from your calculator. Okay? So, I will take a quick look at a couple examples here. Here it says directions, please graph the following. Be sure to include all intercepts and asymptotes. Generate sufficient points from your calculator to fill in the gaps in your graph. Okay, so that being said, I'll take a quick look at my outline here as I look at the function f at x equals 2x minus 4 over x minus 5. Okay, and if I want to look at vertical asymptotes, the equation of a vertical line occurs at an x value that makes only the denominator of a rational function equal to 0. In short, you've seen this in class. It's set the denominator equal to 0 and solve. The asterisk is, don't forget, is what I'm trying to tell you here is if that value that you find makes the numerator also 0, then you don't have an asymptote. You have a hole, okay? So again, the key word here, it's only the denominator becoming 0 by way of that x value. Okay, so here we go. Real simple. X minus 5 equals 0 because we're finding the vertical asymptote, and that will occur at x equals 5. So I can, in fact, graph that just by going to x equals 5. Decently simple, right? Okay, looking back now at the outline, we will look for horizontal asymptotes. Horizontal asymptotes, you should have covered all this in class, are a matter of degree. Degree comparison between the numerator and the denominator. Okay, so degree again being the value of the largest exponent in that expression. So I will take this knowledge set and take a look to compare the degrees in my given expression, my given rational function, and then come back here and take a quick look at the rule. Okay, so here we go. Horizontal asymptote. I will look at the degree of the numerator compared to the degree of the denominator. The degree in both of them is, equal to 1. And then I am going to take a look for when my horizontal asymptotes where the degrees are equal. That is in this circumstance. So it says the horizontal asymptote will be equal to y equals a over b. Now you should remember from your notes from class that y equals a over b is not the exponents, okay? It's not these exponents, but it's the coefficients of the lead terms. So we get here that y equals 2 over 1, which is equal to 2. Y equals 2 is my equation for my horizontal asymptote. So I'll go to y equals 2 and put that in. Okay? So back to my outline to see what I'm looking for here. Now I need to look for x-intercepts. Okay? X-intercept is also known as a root or 0. It will only occur when y equals 0. Okay? Cover this up a little bit to make this point. These are all synonyms. Output equals range equals y equals f at x. And I want to know when they are, in fact, 0. So really what I'm saying here is I've got this function that looks like a fraction, right? And when is it equal to 0? Well, this should be decently basic in this regard if you think of third grade. The only way to get a fraction that's equal to 0 is when the numerator equals to 0. Who cares what the denominator is as long as it's not 0? So this just means that we're going to set the numerator equal to 0 and solve for x. And that will be the x-intercept. Okay? So let's take a look at that. We're going to take a look at the numerator of this function. First, I'll set it up as the whole function is equal to 0. Again, what I have written here is f at x. Where is f at x equal to 0, also known as y, right? That's a definition you got to understand about x-intercept, right? So again, we have a fraction that equals 0, so who cares about the bottom? Because the only way that fraction can equal 0 is if the top is equal to 0. 2x minus 4 is 0. 2x equals 4. X equals 2. Now that's not the equation of a line, that is a point. So now I will go to x equals 2 and graph that point. Okay? So taking a look back at my outline, I now need to talk about the y-intercept. Well, the y-intercept just means that x equals 0. And you should have that skill from, or that fact from forever at this point in a pre-calc class. So the question is, what is f at 0? That will tell us the y-intercept. Okay? So let's go back to our example and look at y-intercept, which means x is 0. So f at 0 is 2 times 0 minus 4 all over 0 minus 5, giving me negative 4 over negative 5, which is 0.8. Okay? So I'll go to the y-intercept, and I'll put in that dot. Now, there's a lot to be done here when we get to this last part where it says enough points to fill in the gaps listed in an XY chart. So we're going to list in an XY chart some points to fill in the gaps, and we're going to need our calculator for that. Okay? So here I have my calculator. I've already punched in both of the examples I'm going to work on. Y1 is the one that I have here. Okay? Now the one thing you need to keep in mind is that in your calculator, you have to make sure that your calculator is set up under table setup to be in ask mode for the independent variable. Okay, that'll allow you to pick values for x. Okay, so let me actually do that now. Okay, I have my calculator, and I need to generate a list of values. So let me get set up for that. So I've got x, y. Running out of board space a little bit here. And if you notice, I don't have anything to the right of the vertical asymptote, so I'll pick some points over there. And I've got this kind of gap here between 2 and the asymptote, and nothing in the negatives seem to be accounted for. So I'll probably pick negative 6, negative 4, okay? I'll probably pick 4 because it's close to the asymptote on the left. And then I'll probably pick 6 and 8. So simply going to my calculator where I have the function punched in, okay, and going to second table. Now I could type in those values. When I do this, you're going to see values for y1 and y2. y2 is the next example, so just ignore them. Negative 6, negative 4, 4, 6, and 8. Okay? And what's that going to give me? And you can round. You're going to get 1.5, 1.3, and you're going to get negative 4, 8, and 4. Okay? So by making that graph, we get negative 6 gets you this 1.5, negative 4 gets you 1.3, and 4 gets you negative 4, which from there you could tend to see, by the nature of the asymptotes, what you've learned about approaching infinity or negative infinity. Similarly for how a horizontal asymptote works. You could kind of just fill in the graph that way. Now for 6 being an input, we get 8 being an output. And for 8 being an input, you get 4 being an output. And for how we know asymptotes work, you probably can draw the rest of that graph in like this. Okay? Now, the bulk of that is now done, if you notice here. I've got my vertical asymptote here, my horizontal asymptote here. I found my x-intercept and my y-intercepts, and then I've built a chart from my calculator to fill in the gaps. You probably sit there and say, well, why don't I just use my calculator for the whole thing? There's analytical portions of this that are really the crux of the matter. How does an x-intercept occur? How does a y-intercept occur? You know, how does that happen in a function that's represented as a big nasty fraction? Give you a chance to be analytical about these things. Again, the graph is the opportunity to put all these facts together from this comprehensive list and say, can you sort of really do the whole dance of understanding rational functions? Okay? So let's take a look at example 2, and I'll do that again. This one's going to act a little differently here. So we're going to make a comprehensive graph, include intercepts, asymptotes, the whole enchilada here. Okay, I won't refer to the slides here, so make this go a little quicker. Again, we're under the assumption you've seen all these definitions for vertical asymptotes and what have you. So your vertical asymptote here is going to occur when the bottom is 0, the denominator is 0. So when we solve this, you see that you get x equals plus or minus 2. So we've got a horizontal asymptote at 2 and another one at negative 2. So you see this graph's actually going to be broken up a little differently than our last one. Horizontal asymptote means I need to compare degrees. So now I've got the degree of the numerator compared to the degree of the denominator. The degree of the numerator is 1. The denominator's degree is 2. 1 is less than 2. And again, if you just refer to your chart, you'll see that that's y equals 0 for your asymptote. So we just graph that. Okay? Now, going and taking a look at our x-intercept, this means where is y 0, so that it'll be on the x-axis. So I'll set my output for the function equal to 0. And again, the only way for a fraction to be equal to 0 is when the numerator is 0. So I kind of don't care about the bottom. So I get x minus 1 equals 0, x equals 1. So that is my x-intercept. And again, that is a point, not a line. Okay? Take a second and just sort of put some highlight around some of the results I've been finding. Okay? It's nice to have these labels of saying what I'm finding too, even if they're shorthand by saying VA, HA, X Inc, what have you. Okay? And now I will take a look at my y-intercept. My y-intercept means that x is 0, so a way to be on the y-axis. So I'm in fact finding f at 0, which will give me 0 minus 1 over 0 squared minus 4, which is going to give me negative 1 over negative 4, which is 0.25. So right on my x-axis, my y-axis, I'm going to go to 0.25, which I kind of have to estimate a little bit. Okay? And that is that. Now for the table fill-in, okay, where I will pick some values for x and y and generate them from my calculator. We kind of have 3 sections here, left of this asymptote, between the 2 asymptotes, and to the right of this asymptote. Well, I don't have any values on the left, so I'll try and pick, again, it's this kind of a feel thing. I'll pick negative 8, negative 4, and negative 3. Okay? And I'll need to go to my calculator and do some deleting. Okay? Again, I need to look at y2 as I'm doing this, which I already have in my calculator. So I'll get negative 8, negative 4, and negative 3. Okay? And I'm looking at y2 as I do this, and I get I can, sort of estimate negative zero point 0.2, negative zero point 0.4, negative zero point 0.8. Okay, so for negative 8, I've got negative zero point 0.2, and then negative 4, I get negative zero point 0.4, and then negative 3, I get negative zero point 0.8. So it's kind of giving me a feel for where it's going. And using my nature of understanding how graphs will hug asymptotes or approach them, I can fill the rest in there. Draw a line here to show you where I'm sort of breaking that up. Now I have some points in the middle, but it might be nice to get maybe even like sort of a point that I don't have. I guess negative 2 would be nice. And if you really want to see what's going on between 1 and 2, maybe even saying 1.5. You don't have to do that. The more points I pick, the easier it's going to be for me to, oh, I'm sorry, not negative 2. I should have picked negative 1. Somebody in the class would have jumped up and caught that very quickly. And it makes sense that the calculator said error because if you put in negative 2, it's the asymptote value. So I'm sorry, it meant negative 1 and then 1.5. So we got 0.6 repeating is about 0.67. And 1.5, you can see is going to get me negative 0.29. So negative 1 will get me about 0.67. And 1.5 is going to get me negative 0.29, which is here, which then have to have a sense of how asymptotes work for hugging the graph, or vice versa, the graph is hugging the asymptotes, then you have that. Okay, so continuing on, a little more XY chart here. I'll pick some things to the right. I'll probably pick 3, 5, and 7. Sort of spread out a little bit there. So we get 3, 5, and 7. So that's going to give me, again, in the Y2 columns. Excuse me, I missed the 5. And 7. Oh, actually out of space is the problem. So 3 got me 0.4. Okay. And then 7 gets me 0.13. And if I wanted to go and grab up 5, I could just type over something and get 0.19. Okay, which I'll call 0.2. So 3 will give me 0.4. A little hard to graph. Fine tip pencil helps. 5 gives me 0.2. 7 gives me 0.13. But you can see the descending nature of the graph here towards the asymptote. And from there, that'll hug the graph that way. So I hope this has been a help for modeling you. I hope the colors help. If you want to sort of review these in more depth, you probably need to look at more you need to look more closely at the individual components. Again, if you're struggling here, it's because you struggled on a component on the way. So I hope this was a help. Be well, keep practicing.